To measure that movement of the Earth's surface, we use a seismograph. And the seismograph is going to measure the vertical motion and the horizontal motion depending on which way the spool is situated. So if the spool is situated vertically, the pen can mark on that spool as it moves. And if it's horizontal, then as the spool turns, the pen can mark on that. So it's going to measure the ground motion in both ways, vertical motion and the horizontal motion. The pen is weighted on a spring and is going to be measuring then as the drum is attached to the ground. The pen moves along the drum and makes a mark on there to show the wiggles of the Earth's surface. In the olden days, it was just like that. Let me go back. A spool of paper and a pen or pencil that was marking on that, like basically a continuous piece of graph paper. These days, it's done a little bit more sophisticated, I suppose, with this electrical current going through here and a magnet that is going to move, and that coil in the middle that stays in place. As the magnet moves, then it's going to record the seismic energy. We can even do it remotely in one of these little gadgets here. You can just take it and set it, and it has a similar setup where you can have a fixed point and then movement with these coils on the edges. So it looks like this. If we were using an old school seismograph, here's the piece of graph paper, the spool cylinder of paper here, and the paper is moving along as the pen shakes. So the first thing that is marked on here is the P wave arrival time. And then after the P wave arrives, there's going to be some time before the S wave arrival time. Those two waves coming from the body of the Earth are going to intersect the surface, and that's going to generate those surface waves. So here are all the surface waves that happen later. That seismic energy is going to die off, and anything that happens beyond the P, the S, the surface is going to be a little blurb there of an aftershock, so later in time. All right, so here is the epicenter, and the wave's energy propagates seismic waves away from that epicenter. On this diagram, the green waves are the P waves. Remember, they are body waves that are the fastest, so they're moving along the surface of the Earth. Behind them in red there are the S waves. They're going to be moving a little bit slower. So they're both generated from the same epicenter. They're going to move towards seismic station 1, towards seismic station 2, towards seismic station 3. So there's going to be a gap in time where P arrives at seismic station 1, 2, or 3, and then later on the S wave arrives. That's the SP wave arrival time difference here. So here is station 1, P arrives, a little bit later is the S wave. Station 2 is a station further from the epicenter, so it takes a little bit longer for P to arrive, and then there's a longer arrival time difference between the P and the S wave. And then station 3 is again further from the epicenter, so P wave arrives later, and there's even a longer time between the arrival of P and S. So the bottom line here is the further the station is away from the epicenter, the longer the PS wave arrival time difference is. And we can use that number, that arrival time difference, to determine the distance of the stations from the epicenter. And that's in this graph here. So travel time is on the y-axis here, and distance between epicenter and seismometer is on the x-axis. So that's in kilometers, and the vertical is in minutes. So the P wave is the bottom wave here along the bottom, and the S wave is so that's the fast wave. The S wave is a slower wave, and its trajectory is here along the top. The difference between these two lines on the graph is going to increase. That's the difference between S and P arrival time, the further away from the epicenter. So these three vertical lines represent station 1, station 2, station 3. The widening of the difference between the two red lines is the growth in the difference between the SP wave arrival times. Okay, so we can use the SP, this is the same graph here on the bottom right corner. We can use those SP arrival time differences then down here on the X line, the X axis, we get that value, the distance between the epicenter and the seismometer. So if we take a compass, it has a pointy end and a pencil, and we can draw an arc with that around the epicenter. Here's the compass. We can draw an arc that represents that distance between the station and the epicenter. If we do that for every seismic station, the three arcs should close in on a point, and that point would represent the epicenter where the rupture occurred along the fault.